Yeah, because it's in the last lesson and it talks about it just towards the beginning.
I can hear. Yeah. So we're trying to get the p-value. You have to put in a percentage.
It's not a percentage, it's just it's like a kind of what you're comparing your mean sample to. Because it says your null hypothesis will state the mean sample which is equal to some number. Enter that number as the test value. This is a step people often forget to do. This tells SPSS what the value of U is in your null hypothesis. So I guess it would be 0 in this case.
Well, I wish mine would come up so we could do this.
Yeah.
You got yours to work?
No, I didn't. I just opened up the test to see kind of what's on there.
Okay. Liam, don't. Okay, so what the fact the data pulled up?
Did you get it pulled up?
Talking to me?
Anybody? Does anybody have the data pulled up?
I'm downloading this
I don't.
this program right now. It's taking a while to open.
I couldn't get it to open up.
Okay, well, I just did it for me. Yay.
minutes out. I got like 3 minutes for this thing to finish doing whatever it's doing.
Okay. So we're gonna. Is that what we do
What's that?
to figure out the difference of the means, or the difference of the pre and the post? Okay, go to compute variable. And then post my pre.
Oh.
You have to type the target variable, you have to kind of like highlight the name of the group you're wanting to figure out the information on.
Yeah.
So you put in difference, okay, and then post minus the pre. Do you put an equal sign? Does it say?
No.
Okay. So I've got the difference. Okay. So now the question is, we have to analyze okay. Enter key. Does anybody have the answer key pulled out?
Yeah.
So is the mean negative 1.05
For what question is this?
In number 3, where you're describing the data, you're putting in the mean, which is U subscript D.
Yeah. It says 1.056, depending on which way you subtract it, pre minus post or post minus pre.
So I did post minus. Okay.
Yeah.
So the standard deviation was 2.596.
Yeah.
And then the sample size was 9.
Yeah.
9. Okay. Okay, so now I'm going to find the test statistic. So I'm going to go up to Analyze and Compare Means. Then one sample t-test. And I highlight the difference. Okay, I see what you're meaning, BG, about the test value.
Yeah.
That's where you put the mean in.
Yeah, I'm not sure which one. It would be what number?
When you did that, it was usually the... Was it X bar? The sample mean, is that what you'd usually put in there?
Yeah.
Okay, well, I'll just try it at 0 and we'll see what it says compared to the... So is the t-score a negative 1.220?
Let's see. Yeah.
Okay, so you do put in 0. So it's negative 1.220, and then it shows the degrees of freedom is 8. Is that right?
Yeah. Yeah.
Okay. And now the p-value, that was where we got the two-tailed there. So it was 0.257, is that right?
Yeah.
Okay. Sorry I wasn't following you what we were doing because I didn't have my thing up. I thought we had to put in percent. Okay. So, having known that it is 0.257, that's bigger than, what do you call it, alpha? What is it?
The level of significance.
So it's higher than the level of significance. So we fail.
To reject that all.
So that means the null is right.
Yeah.
It means there is no change with his new procedure, right? They don't get any better or any worse. It's just the same.
Yeah.
Okay.
Yeah, because here it says we have insufficient evidence to say that the time to make 100 products is any different after the implementation of the new assembly procedure.
So, H, rather than testing a hypothesis, now say you just wanted to estimate the difference between wait times at the 95% level. what would you do?
So I'm pretty sure you have it there already.
Yeah, the lower, let's see. So is it asking for the confidence interval?
Yeah, of 95%. And they automatically, when you, yeah.
So it's negative 3.0508 and 0.9897. Is that the answer key? Okay.
Yeah. Yeah, because it's usually always, it will put in the 95%, and if you want to change it, you'll go in and do that.
Okay. Yeah, if it was a different percentage, yeah, you'd go and change it, but it automatically goes to 95. So it wants to know, describe the action you feel you should be taken based on the statistical results above. So basically,
Just look for a different plant to reduce the amount of time to make 100 products.
David, are you still there?
Yes, I just had to. I'm trying to download this thing. That's why it's taking forever. Sorry.
Okay, as long as you can kind of follow along. We're ready to do the test now.
Yeah, there's 18 questions.
Hey, were you guys using the key just now, like to help you verify your answers?
Yeah.
Yeah, I've got the program pulled up.
Well, no, because like on my key, because I was listening in and I was going in over the key answers, what you guys have, and there was a couple that my key didn't have any answers to that DG was saying that there was an answer to. So I think there's something wrong with the way my computer's downloading stuff.
Oh.
Yeah. But there was a couple answers on the key that didn't show on my key.
Yeah.
Anyways, sorry.
So just, so do we want to do the quiz now?
Yeah. Okay, I'm pulling mine up.
David, do you have your quiz open?
Yeah.
No.
Okay, let's start.
Okay. So 3 says, suppose we have a set of paired data and let D equal x after minus x before. The null hypothesis is the mean difference equals 0. The alternative hypothesis is the mean difference is not equal to 0 and the population standard deviation is not known. Jordan collects a sample of size n equals 9 and computes d equals 2.2 and samples standard deviation equals 3.3. What is the value of the test statistic?
So we have to do it by hand here.
Yeah. So that's like the formula where it's like t equals x bar minus u divided by s divided by square root of n, right?
Yeah.
So here, x bar, is that 2.2 then?
Yeah.
And
That's
so
what I'm
what's
thinking. Would be 0, right?
and then the mean would be 0?
Yeah, well,
Like
look at what we've done in the past when in the hypothesis what the number is, and that's usually the mean, right?
oh, yeah, I think so. Yeah, because D, like the D with the slash or bar over it would be equal to like X bar, wouldn't it?
And that's what I'm thinking. So we're gonna go 2.2 minus 0. Yeah, minus 0. Hang on, buddy. S.
So I just got 2.
So it would be 2.2 divided by 1.1?
Yeah, that's what I got.
Yeah, it's 2. That's what I got.
So yeah, I'm pretty sure that's right.
Okay.
David, did you get that?
Yeah. That's 2.2 divided by 1.1. Nobody's doing it for? Okay. Okay, the probability of being greater than 2 is 0.0403. If the alternative hypothesis to determine the p-value for this test. Oh, the alternative hypothesis to determine the p-value for this test. So our alternative hypothesis is the equal sign with a slash through it, right?
Yeah.
So it's the same thing, 0.0403 or 0.040.
It's the same thing?
Well, how would we find the p-value for that?
Yeah, I don't know. I was looking through my notes right now.
Because that's what the p-value is the probability.
Okay.
Wait a minute. Oh, okay, it's wanting to know if it's greater. What's the probability of it being greater? So the p-value for this whole test it's going to be both of those. So you times that by 2. Does that make sense? We're wanting to figure out both sides, the probability of both sides. This probability they're giving you is a one-sided probability because it's a probability of being greater than 2. We want to know both sides.
So then you would do
that 0.0403 times 2 to get a two-sided probability.
so then what they did was basically, you know, like when you go into the p-value, and if it's a one-sided, you divide it by 2. And so now what we're doing is just timesing it by 2 to get both sides.
Yeah.
But do we just want the greater side?
Huh?
Do we just want the greater side, or do we want both sides?
No, because this particular test, it gives us the information above. It wants to know in the says use the alternative hypothesis. And the alternative says, doesn't say it's greater or less than both. So that's why I do both. Zero. Oops. So did you get a 0.081?
Yeah, or 0.08. I got 0.0806, which I can round it to just 0.81.
Yeah.
Yeah, that's what I got. Okay, so next one says use a data file, chapter 12, data A, to answer questions 5 through 10. Make a column of differences in SPSS using null hypothesis of UD equals 0, an alternative hypothesis, mean of difference equals not 0, and the level of significance alpha of 0.10. What is the difference?
And there's the motorcycle on the back.
So, chapter 12, data A. Chapter 12.
I got mine pulled up.
Alright, mine's pulling up right now.
We're making the difference column.
Yeah.
Okay.
Another one.
Oh, shit.
Another one.
Okay.
Does it say which group is which?
No. That's why. Yeah, I was reading it again to see what. I'm just guessing we would do group 2 minus group 1.
Yeah.
Okay.
Oh,
So now we have to find the mean.
Yeah.
Good job, man.
So I got mine. But so does it matter if it's a negative or positive?
Well, do you remember in the thing, it's, what did it say in the answer key? Didn't it say answers may vary?
Yeah, that's why. Because yeah, it said it was either negative or positive. Like the answer was both either negative or positive.
So I think, because I got a negative 31.025.
Yeah, that's what I got.
I'm still downloading this stupid thing. Sorry, guys.
It's okay. So it asks what is D?
Wouldn't that just be the difference mean?
Yeah. So negative 31, what was it?
0.025.
Liam, it's too cold to go out in shorts. It's really cold outside. Okay? You need pants on. You get sick. So what is the standard deviation?
So I got 341.157.
Look over. 341.157. Let's see. Okay, the test statistic. Where do we go? Oh, there it is.
Yeah. Did you find it?
Just pulling it up here. 0.407.
Negative 0.407?
Yeah, did you get that?
Yeah. So for the
Okay.
p-value, I got 0.689.
Okay. That's what I have. Okay, so it is, the level of significance was a 0.10.
Mm-hmm.
So it is greater, so we failed to reject, right?
Yeah.
Okay, suppose your alternative hypothesis greater, it'd still be the same, wouldn't it?
Let's see. So the alternative hypothesis is
Can you make me turn?
yeah, because it has to be lowered to reject a null, right?
Yeah, that the alternative hypothesis has nothing to do with whether you reject or fail to reject. It's a p-value, right?
Oh, okay, true, yeah.
Okay, hang on. I'm gonna pull up this other data thing and then gotta go make some toast.
Okay.
So which is greater, the sample or the degree of freedom?
Well, we get that through the data, don't we? Like once we make the...
Yeah, you gotta find the... Yeah. Okay.
Oh, well, isn't it n? Because the degree of freedom is always going to be n minus 1.
Right.
So then n will always be greater.
Hey guys, quick question. When you guys downloaded your SPSS, did you use the Unicode encoding? Wait, on the Unicode encoding or the local encoding?
Is there something highlighted automatically?
Yeah, they use Unicode encoding.
I think I just used that.
Yeah, I think
I
I
didn't
just...
know anything, I just clicked OK, whatever. So the sample size is always bigger. Okay. So the next one. Okay, so gotta find the p-value.
I got 0.001.
Okay. And it is that because it's two-sided. One-sided, we'd have to divide it in two.
Yeah. And it'd be even smaller, so...
What's the level of significance? 0.01. What? Oh, 0.001. So it's smaller.
Mm-hmm.
Reject the null.
Yeah.
So this next question, it says you changed the null,
Alternative.
or yeah. So it's just one-sided now. So your p-value is gonna get smaller.
Oh, okay, yeah.
So if it's smaller, you'd still reject the null.
Mm-hmm. As we have seen, the p-value depends on the alternative hypothesis. Setting aside the data in this problem, do you think a general rule can be made? Which alternative hypothesis will give the smallest p-value?
Hang on, let's back up to number 10. Where I
Okay.
talked
Oh
about
yeah, that's where. Yeah.
where I talked about the alternative has nothing to do with it. It does.
Mhm.
It's cutting that 0.689 in half. So we got to cut that in half and see what it says.
So 0.689. 0.346.
Okay, so it's still bigger.
Yeah.
So we still fail to reject.
Mhm. Okay. So which alternative hypothesis will give the smallest p-value?
Where are you?
On 16?
Okay.
So the not equals a 0 wouldn't, because it'd be a two-tailed.
Well, it could be both of those, greater than or less than. As we've
Yeah.
p-value depends on the alternative hypothesis. Setting aside the data, okay, you have to have the data.
So would it be not enough information depends on the problem?
Well,
Yeah,
and
because it can't automatically just be greater than or less than.
setting aside the data, do you think a general rule can be made? Yeah, because if you set aside the level of significance, well, even if you had all the information, you would have to mark both the greater and the less than, because they'd both be equally small. Well, wait a minute. Yeah, because whatever the slash or the equal sign, if you have one of those other ones, you're automatically going to divide it in half.
Yeah.
So it's a tricky question. If you could highlight both of those.
Yeah, then.
You can't. So I would just say not enough information. Because you do have to know the level of significance.
Yeah. And like you said, for either one, you would divide it by 2, but depends on the level of significance.
Right.
Hey, you guys,
Okay.
how do you guys, so you know how it says right here, it says chapter 12, data B? Like, where do I find that in this? Like, stuff here.
Like you can go to your reading.
And just click on.
If you want the website, it's statistics.byuimath.com /index PHP. I don't know. You might be able to get it for just doing statistics.byumath.com.
That's where you get all the information from?
Yeah, that's sort of that's the database.
Oh, okay. Okay.
So for 17 and 18, is it just asking from the last difference that we found, right?
What?
So for 17 and 18,
Wants the confidence intervals for the lower and the upper.
yeah, for the last data file that we did, right?
Yeah.
Okay.
The chapter 12B.
Mm-hmm. So I got for the lower negative 18.607, I rounded it, and then the upper was negative 5.303.
I got different from that. Let me make sure I've got the right.
Let me make sure.
I've got chapter 12 data B1.
Let's see. Mhm. That's what I have as well. Yeah, that's what I have. But I got the same thing. I did it again.
I got a negative 190.6915.
Oh.
Is it for the difference?
So you did it through Explore or where?
Yeah. I'll do it again real quick.
Okay.
Okay, I've got it different.
So you said you had what? Or what did you get?
Well, I think I've got the numbers you had. What did you have?
Oh, I have negative 18.6065 and negative 5.3025.
That's what I got.
Oh, okay. So do we want to round it?
That's what they usually have you do, is to the last three.
Yeah. Alrighty.
What did you get for rounding?
Negative 18.607 and negative 5.303.
Okay.
All right. Did you get those, David?
Yeah.
Okay.
Will you go over them so I can check them?
Yeah. All right. So 3 is 2. 4 is 0.081. 5 is negative 31.025. 6 is 341.157. 7 is negative 0.407. 8 is 0.689. 9 is fail to reject the null hypothesis. 10 is fail to reject the null. 11 is n. 12 is 0.001. 13 is reject the null. 14 is decrease. 15 is reject the null. 16 is not enough information, depends on the problem. 17 is negative 18.607, and 18 is negative 5.303.
Do you think we do need to round those? It doesn't say to.
I know, that's what I was thinking. Should we just keep them the same, like 60, what is it, 60,
6065.
606 to the third, or just all the numbers? Because remember how he was saying either way, when you round it, it kind of gives like a leeway between this number to this number.
Yeah, I guess if we're gonna just do the third number, you might as well just round it, leave it the same.
Oh, okay.
Okay, I didn't get number 6. You got 341.357. Is that right?
341.157.
Oh, 157.
Yeah.
And then can you repeat number 4 real quick? Is it 0.081?
Yeah.
Okay, there's one on here I had wrong. For number 5, did you have negative 31?
Yeah, negative 31.025.
Oh, okay.
So for those last ones, do you guys want to round them or just keep them how they are?
I'm looking at the past assignments to see.
Because he said usually we'll round, won't we?
Yeah, I'm just gonna leave it rounded as it is.
Okay. Yeah, me too. So. Alright, so everyone got, so are you good, David?
Yeah. That was sticking with the negative 5.303.
The what?
On 18 and 17, we're sticking with negative 18 and negative 5.303 and 0.607.
Yeah.
Okay.
Okay, I'm gonna submit it.
Nice.
Good job, guys.
Guys, come on, it's freezing. Come on, run.
All right,
I
man.
don't think.
My buddy Blake, he's gonna call me tonight and teach me how to use the SPSS, and I'll be more helpful next week, or Thursday. So
Yeah, sounds good, man.
sorry about that, but
No, you're good.
I'm trying to get all that done before Thursday. That way I can
Yeah,
have the answers ready. So
you're good. Alright, man.
Okay, see you guys later.
Alright.
Okay.
Bye.
Bye.